Let's sketch the Lewis structure of SF4, also recognized as sulfur tetrafluoride. We can draw the Lewis structure of sulfur tetrafluoride using these simple steps. First, we'll sketch a rough diagram of the structure. Next, we'll depict the chemical bonds between the atoms. Then, we'll determine how many lone pairs to place on the individual atoms in SF4 and ensure that all the atoms satisfy the octet rule. Finally, we'll calculate the formal charges, verify the stability of the structure, and aim to achieve the most stable Lewis structure with the smallest possible formal charges. To draw a rough diagram of SF4, we first need to calculate the total number of valence electrons and then identify the central atom. The total number of valence electrons in SF4 can be determined by summing the valence electrons of each atom in the molecule. Sulfur, a group 16 element, has 6 valence electrons, while fluorine, a group 17 element, has 7 valence electrons. In SF4, there is 1 sulfur atom and 4 fluorine atoms. Therefore, the total number of valence electrons is calculated as 6 plus 7 multiplied by 4, which simplifies to 6 plus 28 equals to 34. Thus, SF4 has a total of 34 valence electrons. To determine the central atom in SF4, we place the element with the lower electronegativity at the center. Since sulfur has an electronegativity of 2.58, which is lower than fluorine's electronegativity of 3.98, sulfur is chosen as the central atom. Thus, in the rough sketch of SF4, we place the sulfur atom at the center and arrange the 4 fluorine atoms around it. To represent a chemical bond, we can either place 2 electrons or draw a single line between the atoms. In this case, we will draw a line between sulfur and each fluorine atom to indicate that sulfur and fluorine are chemically bonded. Since a single chemical bond represents 2 electrons, we have used 8 electrons to form 4 chemical bonds. As calculated earlier, we had a total of 34 valence electrons, and after using 8 electrons for the bonds, we are left with 26 unutilized electrons. Lone pairs consist of electron pairs that are not involved in chemical bonding. Remember that each lone pair contains 2 electrons. As discussed, we have 26 electrons remaining that are not yet utilized, so we can form 13 electron pairs and represent them as lone pairs on the structure. It's important to remember that sulfur is a period 3 element and can hold more than 8 electrons in its valence shell. In contrast, fluorine, which is a period 2 element, cannot accommodate more than 8 electrons in its valence shell. Another important point to keep in mind is that lone pairs should be marked first on the outer atoms, followed by the central atom. In SF4, each of the 4 outer fluorine atoms is assigned 3 lone pairs, while the central sulfur atom receives 1 lone pair. This distribution accounts for the total of 13 lone pairs available in the structure. In the current structure, each of the 4 outer fluorine atoms, as well as the central sulfur atom, satisfies the octet rule. Now let's calculate the formal charges to assess the stability of the structure. This is the formula we can use to calculate formal charges for the SF4 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Just input the data and allocate the values to obtain the formal charges for each individual atom. For sulfur atom, valence electrons equals 6, non-bonding electrons equals 2, and bonding electrons equals 8. So, the formal charge will be equals 6 minus 2 minus half multiplied by 8, which equals 0. For each fluorine atom, valence electrons equals 7, non-bonding electrons equals 6, and bonding electrons equals 2. So, the formal charge will be equals 7 minus, 6 minus, half multiplied by 2, which equals 0. The formal charges on the sulfur and fluorine atoms are indicated, and it is clear that the current structure is stable, as all formal charges are 0. Therefore, this structure can be considered the stable Lewis structure of SF4. To summarize, each line between the atoms in this diagram represents a bonding pair of 2 electrons. The final stable Lewis structure of SF4 shows that the central sulfur atom is singly bonded to the 4 outer fluorine atoms. So, that's the Lewis structure of SF4. If you found this simple explanation helpful, press the like button, share the video, and subscribe for more.